Hey guys, in this video we'll learn about the basics of vectors and go over vector notations. This is a video in my Calculus 3 series. Also, I have a video in my calculator tutorial series that demonstrates how to graph vectors and do vector calculations on the TI-84 Plus CE graphing calculator. The link for that video will be in the description below, so check that out. In this video, first I'll introduce vectors in 2D and then discuss vectors in 3D. Without further ado, let's get started with vectors. You may have heard that a vector has a magnitude and a direction. But what does that really mean? Let's say you told someone that you left your house, which let's say is this one, and ran at a speed of 2 meters per second for 10 minutes. We know your speed, which is a magnitude, but we don't know which direction you ran in. You could have ended up at your school, which is east of your house, or you could have ended up in some restricted area that's south of your house. You wouldn't want people to think that you went to the restricted zone. So you would give them a vector by telling them that you ran 2 meters per second east for 10 minutes. Now you just gave them a velocity, which entails a speed and a direction, and that person knows that you went to the school and not some unwanted place. Some common examples of vectors include velocity, such as the one we were just talking about, acceleration, and forces. Now that we have a general understanding of vectors, let's see how to represent vectors. A vector is a directed line segment with an initial point and a terminal point. The length of the directed line segment represents the magnitude of the vector, and the direction in which the arrow is pointing represents the direction of the vector. In this example, the vector has point P as the initial point and Q as the terminal point. If you are describing this vector, you would write PQ with an arrow on top pointed towards the Q, which is the terminal point. If you're interested in only giving the magnitude of the vector PQ, you would write PQ with an arrow on top still pointing towards the Q in double bars, or sometimes you might see single bars, and then you'd write the magnitude. An important concept to understand is that a vector represents an infinite number of line segments. For example, let's look at this. Let's pretend all these line segments are the same length and they're pointing in the same direction. Although they're in different places, they're all the same vector. Regardless of having different initial and terminal points, these directed line segments represent the same magnitude and direction, and thus they're the same vector. And that is what is meant by a vector representing an infinite number of line segments. Since all these line segments are essentially the same vector, we could represent the vector with a directed line segment starting from the origin that has the same magnitude and is pointing in the direction of any of these lines. Now let's put vectors on a coordinate plane and describe vectors in something called component form. Given the points P represented by x1, y1 and Q represented by x2, y2, the vector with representation PQ is represented by x2 minus x1, y2 minus y1. And they're in angle brackets to represent vectors. When we represent coordinates, we use parentheses. When we're representing vectors, we use angle brackets. Notice that essentially all we're doing is taking the coordinates of the terminal point, which in this case is the Q, and subtracting the respective coordinates of the initial point, which in this case is P. Let's look at an example. We have a vector with an initial point P and a terminal point Q. P is at 2, 2 and Q is at 6, 6. So if we're representing this in component form, we would do 6 minus 2, 6 minus 2, which simplifies to 4, 4 in angle brackets. and this 4 represents the x component, and this 4 represents the y component of the vector. Now if you wanted to find the magnitude, simply take the square root of the x component squared plus the y component squared. To understand why this works, think about the distance formula. The distance formula tells us that we take the square root of x2 minus x1 squared and add y2 minus y1 squared. And when we're looking at the vector, we're taking the components, the x and y components of the terminal point and subtracting the x and y components of the initial point from it. So essentially we're using the distance formula. We have 6, which is the x component of the terminal point, and we're subtracting 2 from that, which is the x component of the initial point, and we're squaring that. And then we're adding 6 minus 2, which is the y components of the terminal point minus the y component of the initial point squared. So essentially we're using the distance formula here. Once you have grasped vectors in 2D, it's quite easy to understand vectors in 3D because all we're doing is considering an additional z component. Vectors in 3D are vectors in space. An example might be wind blowing or an airplane taking off. That might not just have an xy component, it might also have a z component. In this example, we have point P as the initial point, which is represented by the coordinate x1, y1, z1. And the terminal point is Q, which is represented by the coordinate x2, y2, z2. We're using angle brackets for the component form, and just like in 2D, we're doing x2 minus x1, y2 minus y1, but this time we also have z2 minus z1. Similarly, when we're looking for the magnitude, we're considering the distance formula for points in space. We have square root of x2 minus x1 squared plus y2 minus y1 squared, just like in 2D, but this time we're also adding z2 minus z1 squared. So it's quite similar to 2D. In the next video, we'll discuss a way to write vectors using something called standard basis vectors or standard unit vectors. Hopefully this video was helpful. If you have any questions, feel free to comment. If you haven't already, please subscribe. You can also follow my channel on Facebook and post questions there. The link will be in the description below as well as in the comment section. And until next time, take care guys.